I wanted to take a quick minute to talk about one of our sponsors that make this podcast possible, and that's Parker Sporlan and the Catch-All Filter Dryer. Do you know what can reduce system efficiencies and reliability within your refrigeration system? If you answered contamination, you are correct. Sporlan catch-all dryers have been around since 1947 and have been perfected over the years to capture water, acid, solids, debris, including sludges and varnishes. For best practices, change the catch-all filter dryer if any of the following occurs. Initial system install, when a system is open for service or repair, when excessive pressure drop of 5 psi across the filter dryer, when the see all sight glass indicates water is present, when doing a T1-1 acid test kit says there's acid present, during a compressor burnout cleanup, and following a successful burnout cleanup. To find out more information by downloading Bulletin 40-10 from Sporlan.com with all the catch-all filter dryer information. Thanks, guys. Enjoy the episode.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with the host, Brett Wetzel and Kevin Compass. What's going on, buddy? How's your week rolling?
Better than better than the last couple of weeks, that's for sure. Not stuck in chaos, so I'm just doing some dairy cooler startups and repiping some cool gas racks to hot gas to get rid of the cool gas, and some stuff like that. Just trying to play catch up on summer. What about you?
I'm down in Fullerton this week. We're trying to get a bunch of in-person training done by the end of this year, and trying to make sure everything's up to par because, basically we haven't really done any in-person training in a while, because of COVID and everything. So just trying to get everything done. I got some personal stuff going on, so I'll be off for a couple weeks working from home. My wife has to get some back surgery, so yeah, that's what I got going on. Tonight we're going to be talking about, we're going to start off by doing E2 communication failures. How you want to roll, boss?
So we're going to start off going through how to troubleshoot E2 comm issues, how we break it up. We kind of in the last episode, there was a episode in between it, so we went over how me and Brett started addressing some comm issues. Well, now we're going to break it down into different parts, CPC, RDM, if we can get them on, which I think you had that set up, Danfoss, and then hopefully some microthermal stuff. So we're going to start breaking it down into exactly how to troubleshoot this and what you're actually looking for while you're troubleshooting this. So first, we're going to break down a couple terms you guys are going to need to know. So RS-485 is, we're going to go over a couple things with CPC. We're going to go over RS-485, Modbus, and BACnet. We will go briefly over BACnet for CPC. I don't have a lot of experience with it, only a little bit. We're going to spend most of our time on the RS-485 network, and we're going to spend the rest of the time on the Modbus side. So CPC has their own comm network there that is just for them. It is what they call Ionet. That is their comm and board setup. So we're going to go over Ionet first. Ionet is basically an RS-485 communication protocol. It's a 3-wire communication protocol. So you have a positive, a negative, and a shield. Now, you do not always need the shield. We'll explain that as we go through it and some of the issues the shield can cause. But what the shield is there to do is to cut down on the noise and any issues with that. So as we're going through this, we're going to talk about a couple of things. We're going to talk about the PIB board, which is what we call the power interface board. So what the PIB board is when you open up the E2, not the actual door of the controller, the actual where all the wires go, that is the PIB board. So it stands for power interface board. That's where your comms are going to come off. You're going to have, depending on what version of the E2 you have, an E2E is going to have more ports. An E2 is just going to have 2 ports. An E2E is going to have, is it 4 or 6, Brett? I think it's no, it's
What,
5.
COM ports?
Yeah, it's 5.
Yeah, you have 2. You have two for 2, 2 for 4,
and 2,
and then 6,
and 1 for. Yeah, so it's 5. So you're going to have 5 COM ports on there. Now, all these COM ports are configurable. So you could change these COM ports. They could do BACnet, Modbus, LAN, or they can't do LANworks. They can do BACnet, Modbus, IOTalk, Comtrol, whatever you need to do that the CPC could talk to. You could change a communication protocol on this board. Now, this board is also powering the door of the controller. So this is where all your 24 volts power comes in. This is where all your communication goes in. And this is the first thing to smoke when power gets on the network. So this is always going to be where you start usually with COM problems, is checking in at the power interface board. Now, when I say checking at the power interface board, you're going to check it. You always check it when you first get there. Don't power cycle the controller. You want to check from shield to negative and shield to positive. And on Ionet, you should have 2.1 to 2.3 left pin to center, which is going to be your negative. 2.4 to 2.6 right pin to center, which is going to be your positive. And that's what you should have. If your voltage is, say, like 2 or 0 on the left side, then something is dragging down your network. So you want to, that's going to be your spot to start investigating. If you do it on the right side and your voltage is low, or if it's really high, say if it's like 5 volts, something's putting power in the network. So this is things you got to start, you kind of like splitting it up. Now, if you unplug it and you check it at the power interface board and your voltages are good, say 2.3 left to center, 2.6 right to center, then you know that board is, the power interface is good. And if you check it with the pin unplugged, you check the actual plug and you have voltages that aren't in line with that 2.3 to 2.6, it's 1 or 2 of a volt difference, then your issue's on the network somewhere. So then we do what me and Brett started talking about. We start splitting the network up. I go a few boards in, I pull the COM wires apart, and then I test it. See where my problems, starting and stopping. That is the easiest way to do it. Now we're going to start jumping in on some of the boards because there's specific voltages and ways to check certain boards. I mean, some guys will just tell you to do it all this way, but you need a workout guide. Emerson has, and it makes troubleshooting the boards extremely easy. So, Brett, you want to start going through?
Yeah, that's fine. One of the things I did want to say, your voltages, like you said, are going to be anywhere from 2.3 to 2.6, anywhere in that wheelhouse. If you remember, you do have boards putting out voltages as well. So like Kevin had stated earlier, make sure, if you do have it, throwing out less voltage than what it should be, unplug the Mullix connector going to the PIB board and basically check the voltage, at the board with nothing connected. Because remember, you do have boards putting out voltage, as well as, the controller putting out voltage. So like you stated before, you could have something on the network, causing it to dive down. Now, if you unplug the connector and you find out that there's no voltage being put out on the comm loop, at that point, it could be assumed that you probably have something, like you said, out on the network side, on the board side, drawing it down. If you don't have any voltage there after you unplug it, you can reset the controller, because what it'll do is it's smart enough that it'll basically lock out that port, so it doesn't keep drawing it down, and it won't keep trying to put out that voltage. So first off, about all the boards, you have to make sure that you do have the correct transformer for that particular board. And also, like we stated before, make sure it's center tapped or non-center tapped, depending on which board that you have. You do have the, like you had said before, any of the ones that are single boards, the AI boards, the RO boards, the AO boards, the 8 digital output, those have to be center tap. The multiplex boards that have all three on there, the analog output, the relay output, and the analog input, that's going to be a non-center tap board. Most of these boards, they have to be at least a 15 VA for 90% of the boards out there. The E2 VA board has to be given 56 VA. And the CDS board or EPR board, whatever you want to call it, needs to be an 80 VA transformer. So making sure that it's tapped properly, making sure that you have the right transformer on there, as well as making sure that you are getting the right voltage going out. Because you can have one that's tapped for 240, and in reality, it's only getting 208, and you're having a lower voltage put out to the board. Now, they will technically work if it's less than 24 volts down to about, I think their low end threshold is 19, I believe. But I mean, basically, my rule of thumb is, if it's not getting 24, do whatever you have to do in order to get that 24 volts. We don't want it. If you suspect that's potentially the problem, take that out of the equation if you're having intermittent comm loss because of a low voltage issue. So on the boards themselves, they have termination jumpers on the actual boards. Depends on which board that you have. Usually on the multiplex boards, it'll actually show you in which direction that you have to have them to actually be terminated. You only have to terminate these at the end of the loop. So if you're going from controller to IO board, IO board, IO board, IO board, then the last one is going to be terminated. Now, the only time that's not going to hold true is if you have the E2 being basically the center of the loop. Then at that point, you're going to have to terminate both ends. So first board, and then E2 controller, and then last board. Basically, you would terminate at the first board and the last board to make sure it is properly terminated. They do have these jumpers as well on the E2 themselves on the PIB board. It also shows you whether it's terminated for Ionet or Modbus, because that will make a difference. Some networks.
Okay.
Go ahead.
Go ahead. Did you want to go over the difference real quick on how terminated voltages versus unterminated voltages? So when you're checking certain boards, you have to check it both ways. So on a multiplex board, you need to test it terminated. So that a multiplex board, a 16AI, and an RO board need to be tested terminated. So when you're terminated, you should have 2.1 to 2.3 volts DC. When you're on terminated, you should have 2.4 to 2.7. I'm sorry, let me rephrase that. When you're terminated, you should have 2.1 to 2.3 volts DC, left pin to center, right pin to center, you should have 2.4 to 2. This is where it gets kind of wonky. You'll only see this when the comm is unplugged from the board and you're checking in at the board. On terminated, you can have as little as 0.5 to 2 volts left pin and 2.3 to 3 volts right pin. So this is where you may think you have a problem, and those voltages right there would be a bad board if it was a normal board. If it's a multi-flex board, you must terminate it to check it. It will give you those wonky voltages until you terminate it. So that's why you need to look at this guide from Emerson and actually terminate the multi-flex board to check the board. And when you go through it, you could check it on terminated and terminated. But if you don't terminate it, you're going to condemn a board that's not bad. So like a legacy boards like 4AOs, non-center tap, 8 eyes, ARTC boards, you don't have to terminate those to check them.
So I'm reading here, the voltages, it needs to be, the AC voltage going to the board needs to be between 23.5 to 27.5. And same thing with the pins that are center tapped, or the transformers that are center tapped. You should have, from left to center, you should have 11 volts to 14 volts.
Yeah, one other thing, like when you're testing AIs and multi-flex boards, one thing I've seen cause random comm issues is going to be transducers. Anything is drawing power off that board. Transducers, receiver level gauges, humidity sensors, anything that's powered off the board, off the 12 volts, can cause a comm issue, because if it shorts out, it'll actually draw that DC power down on there. It puts more load on the transformer, drops the internal voltage on the board, and now you're getting random comm failures. I don't know how many times I've seen this at a Target where they ran the wire across the roof of the interconnects for the condenser, and they're running them in the, they ran them in conduit up here. Well, not everything was sealed good, and we get a lot of snow. Obviously, you guys don't down there, but all that conduit sitting in snow and ice all winter long. Well, it gets a little bit of water in there. Next thing you know, that ice starts pulling on the cables, and it starts pulling on the cables, pulling on them more and more and more. And then eventually they start breaking and rubbing through, and you get this random dragging down to the 12 volts or the network wire. And it's that. And sometimes it's only when it rains, but that's one thing to look out for. Like, I'll check it if I'm having a board that's going all wonky. I'll check the 12 volts at the board, and then I'll see if it's dragging it down, and seeing if that's causing my issue. If it's just that one board. Now, board itself is just in comm loss. If it's just one board itself, your problem's usually that board. If it's multiple boards, then it's going to be a system issue. Like, so say if input board 1, 2, 3, and 4 are online, output board 1, 2, 3, 4 are online, and 5 is offline, and everything after 5 is offline, I'm probably going to start at 5 if that's where it is in the network chain. I'm going to go right to 5 and check my voltages there. I'm going to terminate my board, and I'm going to check my comm voltages, with the wire plugged in and with the wire unplugged. But generally, like, I would say you're probably safe to assume after that board is the issue, as long as the electricians pulled the comm loop the way that it's supposed to be. After that board is usually your issue. On the E2 itself, if you go into the network tab and hit Alt plus N, you bring up the network tab. You can go into each board. You can see the errors. So you go to each board, hit expanded information. You can see the errors. How long it's failed to respond. You could reset these errors also. So if you're having a comm issue, you could reset the errors, check up on everything. See if you're getting a board with a ton of errors. I mean, that board's probably got an issue. It may be having the DC voltage drugged down by a sensor. It may be having something dragging it down, like a transformer issue. So that's one thing to look out for if you're having a random comm problem. Now, this is a worst case scenario. We had to do this on one store. We had a rack where it was like 6 racks. Every compressor was on a VFD. There was so much noise. Worst case scenario, Emerson had us go through and clip all the shields. So we actually went through and clipped all the shields on every board. So there was no shields on any board. So it only had the 2-wire RS-485 going to all your comms. So all the shields are clipped because they were picking up noise from the actual VFDs. So you want to keep it away from the VFDs. That is the only time I've ever seen VFDs cause issues with CPC, and 460 volt cause comm issues. And it was just random comm issues, like nonstop with the E2s not communicating to the boards. So it actually fixed it. So, I mean, it went away for the most part. Those were E2s. We ended up having to go to E2Es because they have enhanced noise protection in them. So that's what Emerson had us do, is upgrade all the controllers to E2Es. They have better noise protection in them. So it actually went away after that. So you got anything to add to that, Brett?
Yeah, don't ever assume that it's just the board that's the issue, like you'd stated before. Usually, if I have a board that's going on and offline, like you had said before, anything that takes power from the board, whether it be transducer, liquid level indicator, humidity sensor. Usually, what I'll do is I'll see how many comm issues it had in a certain amount of time. Basically pull all the inputs before I reset it and plug it back in, and see if the issues have slowed down. Like if it's keeping the unit running without communication failures at that point, then that maybe one of your inputs had caused it. And you can also do this. Usually on an Ionet they usually do like a 2-minute delay, right? So you can basically time it out. Okay, well it had to run for 2 minutes without comm before before it flaked out an alarm. Well, if you see that the transducer or whatever unit that was on there that was taking power away from the board was going all wonky as far as the pressures or temperatures or whatever it was doing, you can basically see, okay, well that one looks like it's on the verge of going, like it's intermittently shorting out. That's the easiest way to do it. Basically, like I said, unplug all the inputs from there. I don't mean unscrew every single one. Just pull the Molex plug off there. Inputs 1 through 4, inputs 5 through 8, and so on and so forth, and basically do it that way. Also, don't ever assume that the system had been installed properly as far as its terminations and anything like that. I've seen systems that have been running for 10, 15 years and they were running fine. And all of a sudden, this 1 year, it started flaking out and have intermittent rolling comm issues. And lo and behold, it was because the boards were never terminated properly.
Do you have any idea why EMC says not to terminate boards?
I have no idea. It doesn't make any sense whatsoever.
Yeah, it's I ran into this on a target the other day. It was actually in the spec not to terminate the boards.
We talking about Ionet? We talking about Modbus? What are we talking about?
Ionet.
I've never heard that whatsoever.
Yeah, and when I brought it up to them, they said, "Yeah, we don't terminate the boards. It causes more problems," which I've never seen. I've never really seen it cause problems.
No,
I would think it was the opposite way, but yeah, it's either here or there. Now, one thing to really pay attention to, which I never really paid attention to until I actually started reading this manual a couple months ago, is the lights on the multiplex boards, the code A and code B. So that code B light, there's an entire chart. So it has 7 different flash codes, and it'll actually flash out like if the voltage is low on the DC comm or on the DC loop for the sensors. If it's the 5 volts low, if it's the 12 volts low, it'll flash out if you have some kind of internal error on the board. some kind of programming error in the board internally. So like that's another thing to pay attention to before you reset that, and then that code's gone. Once it's back online, everything's good. The code's going to be gone. So that's one thing to look at. That code is right in the middle of the board, usually just under like the 12 volt, 5 volt plug. So it's going to be right there. So just pay attention. There's a light that says code A and code B. So just pay attention to that. So that's a brief overview of what you're supposed to have for voltages on Ionet. Ionet's pretty simple. I mean, splitting up your network is the easiest way to troubleshoot comm stuff, especially if the whole store is down. Just split it up and start split the comm network in half, and then start troubleshooting from the E2 back. Get half of it online, and then keep going. I mean, don't expect. I mean, it could be multiple things. I mean, like Brett said, it could have been messed up for a long time. There could be multiple issues. So don't just have a board going offline and just really think it's just termination jumpers, because I mean, something else is probably causing it. If it's been like that for a while, there's probably some other issue too. So just, I mean, be aware. I mean, you're not going to be having, boards offline permanently, from a V or something ran too close to a comm line. It's not going to take down the whole store. It's going to be a bigger issue than that. Now, I want to go on to the Modbus network stuff. So Emerson also obviously owns Dixel. So we're communicating with a lot of Dixel stuff now, XM 678, 679s, case controllers, all that jazz. So now we're doing Modbus. Modbus RTU. It's another communication protocol that Dixel's using. So now we're doing RS-485 Modbus. Now, here's the thing. So with Ionet, positive is positive, negative is negative. Okay, now we start talking to third-party communication protocols. This is where it gets kind of tricky. Some things have to be inverted. Some things have to be positive, negatives, negative. With Dixel, Emerson stuff, any XM678, 79s, the case controllers, the case displays, you have to invert the comm. Always do it at the E2. Do not do it at the device. So if on the Dixel, if red is positive, negative on the E2. If black at the Dixel is positive, or if it's going to be positive on the E2, you want to invert the comm. This happens a lot when you're talking to third-party devices. Same thing with BACnet and most third-party devices, whether it be Novar, Emerson. I mean, it depends on how they're doing the communication call. So you want to invert your comm. That's one thing to check. Make sure your comm's inverted. Now, this is the other thing that gets kind of janky is the baud rate. Depending on what customer you have, I mean, you'll see a lot of baud rates at 19.2 or 9600. Me personally, I prefer 19.2. It's way faster. So the Dixel stuff all comes out at 19.2. So you got to make sure you change the Dixels when you address them. And then you have to change the baud rate also to 9600 if that's what your customer's using. You need to check what it is in the E2. The way you check it is you go into the serial tab, you hit Alt-T, hit the next tab, and that'll bring you over to the serial page where you have all your COM ports assigned. You could change the COM ports, any of the COM ports over to whatever you need it to be. It's going to need to be Modbus. So in there, now you're communicating off that. You're going to get generally like 2.3, 2.2 volts left pin to center and about 2.4 to 2.3 right pin to center on the Modbus network on the Dixels. So you should get that out of every controller. You don't have to terminate them or anything to check them. You just unhook the wires and you can check them that way. Unfortunately, with the Dixel stuff, when you unplug you have to actually unwire the comm, because when you pull the Molex plug out, it can't go to the board. Now, when we get to Dixel stuff, 678 lines, when we get to a lineup, we have this problem. Okay, so the first case, the A case, the master case, is going to get the RS-485 connection from the E2. Okay, then it's going to continue on. The comm loop is going to go to the next A case of the next lineup, and the next A case to the next lineup. Only the master case gets the RS-485 network. Everything else on up, so your B, C, and D cases are going to be wired off that LAN port from A to B to C to D. There's going to be a separate loop in every one of these Dixels. The reason they're doing this is so it synchronizes defrost. Say if you were to lose comm with the controller, that controller has its own processor in it. It could run in failsafe. So all this Dixel stuff has its own processor in it. The E2 knowing what to do and writing and reading set points from it, but it is its own standalone entity. So it can go into defrost on its own. So that's why everything go off that master case, off that LAN port, because now you're communicating through that A case to see the B case, the C case, and the D case. So if you look at a print and you have these cases and they're on the same thing and they show one comm loop, technically that's wrong. The RS-485 should hit all the A cases first, go around the store, hit all the A cases, and then from A, B, C, and D, you should be daisy chaining off the LAN port. And on that, it's positive is positive, negative is negative. There is no shields on the LANs. Clip them. So you want to clip them, and then same thing with the RS-4 side. You twist the shield together. I twist them together, and I heat shrink them. So on the RS-45, and then at the end, see this changes every month. It seems like what they want you to do with the end. It's been a resistor here lately, right, Brett? I think is it 250 ohms?
100. It's either no, it's either 100, 120 or 105 ohm precision resistor. They make it in like a Molex plug. Like, so I'm looking, so all these numbers that we're reading off, I'm going to add to the Advanced Refrigeration Podcast Facebook group. But like, currently now they're telling you from the, when doing a Modbus, you basically, the shield coming out of the wire, they want you to earth ground it. They want you to earth ground the controller at the PIB board. And then basically they don't want you to put any grounds to any of the controllers or off the Modbus, connector, the comm loop. And then basically your last one, they want you to ohm it to ground. But then they also have, which they're not showing in this document, but they also, for a while, they were selling I think it was like a quarter watt resistor that's basically shrink wrap with a fork connector on there that they wanted you to earth ground it, but this one's not showing it. So like you said before, I guess it has to do with the firmware versions on how they're doing it, because every so often they change it up.
Well, it's actually them trying to fix issues is what it is, because they had so many comm issues in the beginning. Here's the problem. You have a controller that's almost 20 years old that was never designed to talk to Modbus. It was never designed to do BACnet. And now you're throwing that at it, and they're trying to integrate Dixel into it, who is, not 20 years old. You're trying to make hardware work with each other, and it's where we get these issues. I mean, it took them a while to get it right, but I mean, the last couple of stores, if you follow that grounding stuff, I haven't had any problems with it. It's been pretty good. Now, we were going to go over where we do have the problems, and I think Brett just had this at a store. So is it the XM 678s are the steppers, right?
678s are the bipolar stepper. The 679s are the pulse width modulation valves. Hey guys, I want to take a break and talk about Westermeyer, one of our other sponsors. Today's episode is sponsored by Westermeyer Industries, the leader in oil management and pressure vessels for the commercial refrigeration industry.
Okay, so there's an issue on the steppers on the 678s. Here's the issue. So if you have a stepper valve short, if anything happens to the windings, for some reason, the way the board is circuited, I don't know if it's the commons are all tied together on the boards or what, but the way the board is circuited, it will take 24 volts and put it on the network, and it'll cause the PIB board to burn up. So if you get to a store and your Modbus port and you go to it and you got no voltage coming out of the Modbus port, and there's 24 volts in the network, unplug the tab, check the COM port, left pin to center, right pin to center, see if it's getting any voltage out. If you have no voltage coming out of the E2, you smoke the COM port. Now, say if it's COM 2A and COM 2B, 2A is isolated from 2B, so you could blow up 2A and still have 2B. Do not plug that COM loop into 2B till you find the board that's causing the issue. It is not the hardest to find a board. It kind of is, depending on how the cases are. You go through and unplug them one by one until you find the board. Till the 24 volts goes away.
Well, either that or, because usually when that happens, if you catch it right when it happens, the resistors on the board glow a really, really pretty orange for like 2 seconds and then smoked. And one of the things, if you're dealing with a straight up parallel system, it's a lot easier to find, especially if you're medium temp. And mostly all the cases now are high efficiency cases. So if you don't defrost one whole day, you're going to start seeing high temperature issues, right? And then if it's a parallel system, basically, you could itemize it down to what loop you're on, and basically figure it out that way as well.
Yeah, the other thing with this is you want to install. You're obviously going to have to buy a new PIB board from Emerson. Now, some people say not to do this. Emerson's the one that gave me the part number for this originally. So I install an RS485 isolator. It's not technically an isolator. It is a amplifier. Technically, they're like $17 on Amazon. Basically, what it does is it splits from the PIB board and the cases. It goes to this amplifier. Now, if the 24 volts comes in the amplifier, it blows the amplifier up. I don't care if the amplifier blows up. If the amplifier blows up, I can find the board, isolate it. That's fine. It's $16. I could unplug the COM and put it right into then, and get everything's running now. And I'm reading on the E2 after the board's isolated. Now, that amplifier takes the hit. A $16 hit and you're still running versus a $4 or $5 PIB board. And now it's down to you get a PIB board from Emerson. And the way everything's been, good luck.
So Serial Comm is who makes the one that I saw. Serial Comm, and the model number, it just says type. It's a RS485 surge protector. The part number that I have is a ISO-485-P. And basically that's what we put on all the PIB boards before it goes into the controller. So then that way, basically we don't, you're not spending $1,300 or whatever the hell it is for a PIB board. You're just paying the whatever the surge protector costs and the case controller to fix it. Now, just because, so I thought, and dumb on me for assuming, but I thought that only anything that's hooked up to the actual the local network, right? Whatever is on the 45 directly. So all the A cases, that's what I thought. I was wrong. And I'm glad we didn't replace the PIB board, right away, because he hooked it up, and it was still offline. And basically, I was like, well, let's switch it up, because we disconnected all the A cases because we couldn't figure out which one it was. And what had happened was it actually went through the WAN network. And basically went through the secondary controllers, through the primary controller, and then took it out. So just because it's not on the main primary loop, don't assume that it's always going to be on the primary. Not so much.
Yeah, it's a really weird situation, but I've heard of it happening a lot. And I've had it happen to me enough whenever I'm doing a startup and it has a Modbus loop with Dixel stuff. I just order them and install them. I mean, we put them on the job. It's just not worth the headache or the frustration of not having it and having to deal with it later. $32 over a service call. It's going to cost thousands. especially with me, it's probably under warranty. So, and if they want them out afterwards, then that's fine. But yeah, and to be honest, I think it helps with some of the comm issues. It seems like it helps strengthen the network a little bit, especially the amplifier. The one I use the same one as you, and I've used the powered one also. Did you give the part number for the non-powered one or the powered one?
I don't think this one needed power. I think this was just a straight through and through.
Yeah, the one I was using, it was the same, maybe by the same company, except that you needed a 12-volt power supply, but it was an actual amplifier. Yours is an isolator, I think.
Yeah.
But regardless, it works great and stops the issue. Obviously, you have to fix the board issue, but I mean, other than that, you should be good with that. When you're having Dixel stuff like just drop offline a lot of times it's just at that board. Coffin cases are absolute shit for like that because I don't know why these manufacturers they mount them in the worst spot possible. They condensate, they get wet. Case controllers do not belong under cases. I don't know why these manufacturers keep doing it. And I mean, the Dixels are not sealed. They're not waterproof. They're not rated for that. So any moisture just kills them.
Where else are you gonna put them though? Like, I mean, like on a coffin case, legitimately, like where, I don't think there's any other place you could put them besides underneath. Yeah. You're going to increase the footprint if you try to put some kind of enclosure on the outside, right?
It needs to be like Walmart does it, where they do drops, where they split the case apart a foot and a half. They need to figure out some way to put them in there on the split aparts, or like where we pipe the chases now with PVC. They got to figure out something like that. I mean, coffins, single decks. I mean, I don't know. I mean, yeah, it's gonna be bad, but I mean, when you're replacing $1,000 boards every couple months because of water leaks.
I can just envision this now. I'm imagining Kevin taking a pack out and basically making a case controller enclosure for the damn thing, putting between the cases so he can roll it out on something.
I mean, you might as well you throw a pack out down there, it'd be fine. You won't have any more problems. I mean, same with the SC3 controllers. They shove them up underneath those single decks and they leak a little bit of water and you're done. This is where all the comm issues come in at.
Yeah, most of the issues that I've ever had with most case controllers, 90% of the time it's either an EEV that's shorted out or the whatchamacallit, the moisture.
Yeah, I mean it's a huge deal. And I'll tell you one thing on these new Hill cases where they're throwing them on top. Hill Phoenix is not sealing any of the penetrations, and they run a piece of conduit into the discharge air. Well, if they put some like putty in there, well, it's causing all that moisture, cold air to leak up out of the case into the enclosure on top, and it's causing all the case controllers to get condensation in them, and they're shorting out one by one.
Frozen food, I'm assuming, yeah?
Yes. Fun fact, the XM679 can put 120 volts in the network. We had a store I just did a startup on, and we had one. It blew up like 13 controllers. It blew up every A case controller. And the PIB. Yeah, for some reason the output shorted for the pulse valve, and it smoked the whole back of the board, and it jumped across the board. You can see where it arced, and then it got on the comm loop, and just traveled on the comm loop, and it just went board by board. They went poof, 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 poof. Yeah,
that's awesome. I mean, like what you said before makes sense, right? If it's anything that you could tell that's, if you're trying to figure out if a controller is made for pulse width modulation, that type of valve, it's not going to have a physical relay for that output. So which would make sense on why it's able to short out and basically deliver that voltage directly, through the solid state, through the ground somehow, some way, you know what I mean? Especially if you're combating, moisture issues as well, right?
Yeah, I mean you're just adding to the factor of you're going to get screwed. Let's briefly go over the BACnet stuff. You're going to start seeing this, especially with Emerson. There's going to be a lot more BACnet integrations. I'm seeing a lot of it at these new Amazon sites. They're integrating trained BACnet controllers, rooftops. They're talking right to it. So with BACnet, it depends. Polarity depends on whatever you're doing. Now, a lot of this is going to be Emerson driven. Like they're going to be, they're custom writing programs for this. So you're going to be heavily involved with a product engineer on this. A lot of the BACnet stuff. So BACnet is a open communication protocol with read and write points, and everybody has to follow the same rules of what can be wrote and received on there most of the time. So a lot of BACnet stuff is going to be custom, like rooftop communication. The only Dixel stuff I know that was BACnet was that disaster Walmart controller that they try to do with those next gen Walmarts where they had that horrible Dixel case controller. I'm pretty sure almost all of those are gone by now. So
no, they're still in.
Are they? The three up here they gutted them and put SC3s in.
The one that has the Visiograph on it.
Yep. Yeah, all ours are gone. They got replaced with SC3s when the SC3s kind of first hit the market.
Mm-hmm.
I've never dealt with so many comm issues. Like those things were so finicky. Like the E2 would just lock up randomly. It was just never ending problems.
Well, I mean, it all goes back to like if it depends on the customer, right? If they want the network at 9600 where you're passing too much data back and forth, especially when you got 400 some odd case controllers, right? And I'm exaggerating obviously, but like you got a shit ton of controllers out there that are passing superheat, valve position, and everything else under the sun, and you expect it to talk on a network that you're only going to allow it to do 9600. There's just too much information going back and forth.
Agreed. Yeah. I mean, the faster the network speed, the better. I mean, 19.2 works great. I think you have less problems on Dixel network stuff when it's at 19.2. I know that's what they prefer to run on anyway, but for some reason on the E2, they want to run it at 9600 a lot. I mean, depending on the customer. I mean, but then again, I mean, we're at the end of the life of the E2, so we'll see how the E3. I've yet to get my hands on one. I would love for Emerson to donate one. That'd be nice, but I don't see that happening anytime soon. But yeah, it's I mean that your BACnet comms are all going to be customer specific, whether it's train. That's where I generally see it at. Some random controls. I mean, they could pretty much if it has RS-485 on it or LAN works, you could pretty much communicate with anything with an E2. I mean, Sporlan subcooling controllers.
Calvin, hold on. You just said LAN works.
Yeah, you can do LAN works in E2.
Oh.
You have Echelon.
Yeah, no, you were just talking about BACnet, sorry.
Yeah, you could put an Echelon card in an E2. I mean, I don't know why you would. Echelon's not the greatest comm. It's
very finicky on the it's very finicky on the wiring.
Yes.
That's what it comes down to. And if you have control, if you have an electrician that's not a controls electrician, obviously, a lot of times you don't have the, he's not following the best wiring practices out there.
That's every electrician.
Not all of them.
It's all.
You can't generalize.
Well, you can with those people.
That's horrible.
Yeah. All right, guys. I think we're going to wrap it up for tonight. Next one, we're going to try to do Danfoss or RDM, depending on who we can get a hold of. We'll bring those guys in there, maybe explain their comm stuff a little better. I don't got a whole lot of Danfoss. We get a little bit here and there, and then we had some RDM stuff. I know Brett's got a lot more of it than we do now.
Danfoss is easy. You just do a rescan.
Yeah, that's every other call.
Just do a rescan.
But all right, guys, have a nice night. Thanks for listening.
All right, thanks. Have a good night.